Hi. So, today I'm going to teach you how to differentiate quick and easily. I'm not going to give you any complicated maths or proofs. I'm just going to tell you the method, and that's it. After this, you'll be able to differentiate no problem. So, differentiation tells you how steep a curve is at a specific point. Let's take y equals x squared plus 1. Now, if you differentiate this curve, and then you sub in some values, it can tell you how steep the curve is at any one of these points. So, that's what it is. Now, how do we do it? Well, let's start with the basics. The question says, differentiate y equals x cubed. So how do we do that? Well, first of all, we need to tell the examiner that we are differentiating. We do that by writing dy over dx equals. Now, we've done that bit. So, what do we do now? Well, we take our power of the x, so in this case 3, and we bring it down to the front here. So we have a big 3. Now our x is still there, and we take our power and we subtract 1 from it. So 3 take away 1 is 2. And that's it. Done. You've differentiated y equals x cubed. Not too scary. So what about if there's a number in front of the x cubed, the x squared, the x to the power 4, whatever. So let's say we've got y equals 4x to the power of 3. Now we need to differentiate this. So how do we do that? Well, same as before pretty much. We write dy over dx to show that we're differentiating. Now, our 4 is going to stay unchanged. We've still got a 4 there. Our 3, we take it down to the front. And because it's 4 times x, and 3 times x, as you can see from before, it becomes 4 times the 3. Our x is still there. Now, we take away 1 from the power. So the power is 3, but we take away 1 from 3, and we get 2. So, now let's simplify that. Well, we know that 4 times 3 is 12. So, 12x squared. There we go. Done. Simple differentiation. Now, the next part of this is when you have more than one term. So what if we had y equals 2x cubed plus 3x squared? How are we going to differentiate that? Good question. Well, what we have to do is exactly the same as before. We just treat each part separately. So we start off again by writing dy over dx to show that we are differentiating. Now, treating each part separately, we look at this first part. How do we differentiate that? Well, we've got our 2, we take our 3 down to the front. So it becomes 2 times 3, our x is still there, and the 3, we take 1 away from it, making it a 2. Okay, that's that part done. Now what about the next bit? Well, we have a plus, because the terms are added together, and we've got our 3, we have our 2. The 2 comes down to the front, so 3 times 2. Our x is still there, unchanged. 2, take away 1 is 1. Now let's simplify. So, 2 times 3 is 6. 6x squared, plus 3 times 2 is also 6. And you know from your indices laws, or power laws, that anything to the power of 1 is itself. For example, 4 to the power of 1 is just 4. And in that same way, x to the power of 1 is just x. So we have 6x. And that is our differentiation. So, I'm going to give you an example, and I'd like you to differentiate it when you pause the video, and then I'll come back and explain it when you press play. So, if you could differentiate y equals 3x cubed plus 4x squared. Okay, I'm going to assume that you gave that a try, and I will explain it now. So, first of all, we need to show that we are differentiating dy over dx. Now, same as before, our 3 is there unchanged. We have our little 3, and we take that down to the front. So we have 3 times 3. Our x is unchanged, and we take 1 away from the 3, giving a 2. 3 times 3, x squared. That's our first term done. Now, our second term. Well, they are added together, so we have an addition sign. Now, our 4 is unchanged. The 2 comes down to the front, multiplied by the 2. Our x, again, unchanged. 2, take away 1 is 1. How are we going to simplify this? Well, 3 times 3 is equal to 9. X squared can't be any more simplified. Now 4 times 2 is equal to 8. X to the power of 1, as we know, can just be x. And you're done. Not too hard, right? So, there's just 2 last little bits that can catch some people out. And that is, what if you have something like this, you're differentiating, and one of the terms is 4x. There's no power there, so what do? Well, let's think about this like before. You know that from the previous part of this video that anything to the power of 1 is itself. So we can look at this and think, okay, 4x is the same as 4x to the power of 1. So let's differentiate. dy over dx to say that we're differentiating equals, now our 1 comes down, and so we have 4 times 1, and we take 1 away from our power of x, which remains unchanged, and we have 1 take away 1, which is 0. Now, here's where we have to use another law of indices to simplify. You know that anything to the power of 0 is 1. For example, 5 to the power of 0 is 1. In that same way, x to the power of 0 is 1. So that gives us 4 times 1 times our x to the 0, which is 1, which just gives us 4. So you can look at that and think, okay, when you differentiate like that and there's no power, the x just drops out. You don't need to do these steps in the middle. You can just see that 4x to the 1 differentiated becomes 4. Now that's one of the bits. The second bit is when you just have a number stuck on the end. So what if we just had y equals 2x plus 6? So we're going to differentiate that. dy over dx is equal to, well, we know from the previous part here that 2x differentiates just to 2. Now what about this 6? Well, there's no x there, so what just happens is it goes. It doesn't come down, nothing happens, it just becomes 0. So differentiation of 2x plus 6 is 2. Oh, excuse me, got a stray tick. Now, I'm going to give you one more question and leave it there. So, I would like you to differentiate y equals 4x cubed plus 3x plus 4. I'll give you a minute and then unpause the video. Okay, I'm going to assume you gave that a try. So, let's differentiate. We say dy over dx because you're differentiating, so you need to let them know. Now, our 4 is the same. We have our 3, and we take the power. 4 times 3. X is unchanged. 3 minus 1 is 2. Now, that's one term done. Plus, because there's a plus. 3x, well, we know from the previous page that 3x just differentiates to 3. Okay, that's that term done. So 1 done, 2 done. Now what about the last term? Well, plus 4, we know again from the previous page that if there's no x, it just becomes 0. So we don't even need to write that. Now let's simplify. 4 times 3 is 12. 12 x squared plus 3 plus 0, we don't need to show that, so y equals 4x cubed plus 3x plus 4 differentiates to 12x squared plus 3. With those skills, you should be able to differentiate just about any equation.